Good morning, everyone. Welcome to our AWS User Group NCR Meetup session, and we are thrilled to have you here. My name is Dipali Gulshrestha, and I'm one of your hosts for today's session. I'm joined by my co-organizer Rajat Arora. Before I hand over to Rajat to give you a brief introduction about ourselves, I have been working in IT industry from almost past 2 decades now, specializing into the world of cloud architecture, data engineering, and DevOps. In AWS space, I have obtained few certifications like Cloud Practitioner, Solutions Architect Associate, and Solution Architect Professional. And I'm proud to be an AWS hero and a passionate LinkedIn Learning instructor where I have published few courses on AWS, which can be a great resource for you to help you in your AWS journey. I can share these links in the chat. But before that, Rajat, would you like to share a few words and introduce yourself?
Sure, thanks Dipali, and please excuse I'm facing some issues with the video sharing today. So, hi everyone, very good morning and welcome to the session for the containerizing with AWS. So, myself Rajat Arora, I have around 18 plus experience working in IT industry, primarily around working on the full stack development, which involves UI development, microservices development, backend development, and a full application development. Initial stages of my career, I used to work on the old Java technologies, which is Servlet and JSPs, and then gradually learned microservices architecture, distributed architecture, worked on various virtual machine and distributed application architectures, and now working on the containers and DevOps area. So I will be sharing up with my experiences today so that I can share how the industry has changed, what the new technologies are coming up, and how we can leverage them as a best practice to design the next gen applications. Along with that, I'm a part of AWS User Group Community Delhi, and I got a second time AWS Community Builder tag this year, so I'm supporting this community effort along with Dipali.
Great. Thanks, Rajat. So, as you all know, today's session is focused on diving deep into the container concepts and to learn to containerize on AWS. And we encourage everyone to ask questions, share your experience, and participate in discussions via chat. And we also have some AWS credits to share with you guys. So, but yes, those credits will be available only to the active participants. So please be active and make this session more interactive. Without further ado, let's get started. So Rajat, you can see my screen, right?
Yes, I can see the presentation.
Perfect. Rajat, yes, over to you, please.
Okay, so let's try to understand what are the typical working styles of developers and how developers work on the ground and in office. So developers are very smart people, I would say, because they have been given a high level requirement which is very ambiguous in many times. There were no clear instructions and they've been just asked to develop some software or a small piece of software, like just write a basic API. They have not been given too much information like what exact uh, let's take it if they've been asked to develop a Java API. The clear instructions are not given to developers, like what Java version they want to use, what is the exact version they have to use, how they have to design the API. Just given to them is like design a API, maybe a customer API, perform some create, read, update, delete operations on this customer API, and then develop something which is working. And then once developer develops something, then they get better feedback, how to improve it, what is the right naming convention, and then all these things comes into the picture. So for making those things work, a developer has to go through multiple cycles of development of a single piece of code. So before that, they install some tools on their local desktop, So if it is a seasoned developer who are working on this desktop for last 1 or 2 year, they have lots of different tools which they used in their old projects, lot of different settings that they do their own desktop and laptops to make those things work. And typically it includes installation of language runtimes like Java Virtual Machine or Python runtime, npm node versions, setting up some environment variables so that a right Java would be picked up from where to pick up the other settings. So a lot of things being configured in environment variables. Then they do some proxy settings as well, so that if they're working in a secure environment, a developer can reach out to internet, download stuff from the internet. It can upload stuff on internet. uh, Along with that, just with the code structure, they do a lot of other customization as well, which is outside their code folder. Especially if you are a Java developer, you have a Maven settings, which is outside your code folder, which is .m2 Maven settings. It's particularly known as .m2 Maven setting, which talks about which credentials you need to register to go to maven.com to download the external jar files. And there are a lot of things that developer do, setting up SSL certificates, installation of SSL certificates to open a website or to make a connection to a website, along with some kernel level settings as well. So developers, I'd say, they're very smart people. They do lot of things to make their code work on their machine. So kernel level settings may be enabling the Hyper-V settings, enabling the virtualization settings in the BIOS. They go and they do those changes as well. Then they use different IDE like IntelliJ IDEA if they are working on a Java or PyCharm, or if you're using Eclipse. So developer use different type of IDE as well. So maybe some developers are comfortable with Eclipse, some are comfortable with IntelliJ IDEA. So they keep on using different IDs as per their preference, and each ID has their specific settings for the configuration. Like IDEA settings are totally different than what settings being done in Eclipse. And then developers do a lot of DB installation as well. Again, like when developers work, they have a very short time to set up the things and make things work. So they download very, I would say, so many softwares which are free trialware, this just to make their work done. So they do a lot of DB installation, configuration, and many other things. And they also download a lot of debug tools as well, like Wireshark to intercept the HTTP traffic and many other things. So there are so many settings that a developer has to do just to make a basic code run. And over the time, when developers do a lot of settings and they have been asked to ship this code to the other person who can be another developer, like checking this code into a common repository which is GitLab or GitHub, so that it can be shared by other developer or it can be given to QA for testing. So maybe we can move to the next slide now. Let's see what happens next. Dipali, over to you.
Okay, sure. Thanks, Rajat. So yeah, in short, as Rajat explained, means when we develop any application, we need to do a lot of settings. We do a lot of installations. We install some runtimes, some libraries. We do some configurations. But yes, eventually, when we want to run the like same application on some other machine or in a different environment, generally this is the typical problem in a software engineer's life. That but it works on my machine. We always end up saying that yes, it was working on my machine. I'm not sure what's wrong in this environment. And then at times we also used to face this sarcasm that perhaps it was only your machine where it was working. And nowadays people have like similar complaint to even chat gpt, that they developers grab the code from chat gpt and they're complaining it back that whatever code you provided, it wasn't working on my machine. And chat gpt also ended up saying that yes, it works on my machine. So this is a typical problem in software engineers life. So this is where containers comes into the picture. So how containers try to solve this problem, that what containers suggest, that why to ship your just application code, because so far what we are doing, whatever our application is script, we are just deploying that application script into a different environment. But with containers, this concept says along with your application script, let us package everything together, whether it is your environment details, your configurations, your libraries, runtime. So let us package everything in a box, which is known as container, and then ship this entire box into some different machine or in a different environment. So your application has everything which it needs to run, and there is no discrepancy in terms of versions, in terms of any other dependency or different configuration or something. So you are safe, so you have everything packaged in one container in one box and shipped it to a different environment. So this is the official definition of container, that container acts as an abstraction at the application layer which packages code and dependencies together. So here what happens, like instead of just virtualizing the entire physical machine, container virtualize the host operating system only. So let's understand this line in bit more detail so we can actually understand um, what the intent behind it.
So just to add
So
one more thing, so if you go back,
mhm,
Dipali,
sure, Rajat.
so what typical changes container brings in, like instead of making all the configuration changes that are described earlier by developer on their local machine, because they're doing it lot of things outside their code folder and outside their id settings as well, which brings the problem. So that is where container says, like whatever settings you have to do even at a developer machine, do it along with the container. So you can see lot of arrow here, like container contains a configuration, contains a code, it contains a runtime version, it contains a libraries, it refers an environment variable. So all these things has to start from a developer machine itself, so that whatever developer is working that code, making that code to work, it's doing along with the container, so that that container can be shipped separately to the separate machine.
Yeah. And why these containers are so popular these days? Because it addresses all these challenges. Along with that, these are known to be as like next generation of the virtual machine. Because in case of virtual machine also, we have these are like completely isolated environment from your host machine. But on top of that, containers are pretty lightweight. So if we try to see this like architecture of containers and virtual machines, so here you see that basically like the key difference like between containers and virtual machine is that they just have the different ways of virtualizing. Otherwise it's like more or less same, that you have some like host infrastructure, you have some infrastructure here, and on top of that you have some host operating system, and then you are running your application on top of that. But in between you have got this one another layer. So in case of virtual machine, it is known as hypervisors, while in case of containers, we have here Docker runtime. So this is the something which is making it different. So how it works is like, so each virtual machine actually, if we look at this layout, so each virtual machine, it comes with its own guest operating system, as you see here. And this guest operating system, obviously considering it is a operating system, so it is heavy. Now the application which is running inside this virtual machine, how it communicates, how it gets the required infrastructure when it is running on this host operating system. The way this process works is that this application communicates with the guest operating system, and this guest operating system in turn talk to with the host operating system. And then this host operating system actually allocates the required resources for this application from this physical infrastructure to run this application. So this is the way virtual machine works. Now as we see here, means this is a long chain, there are multiple hops in order to means allocate the required resources for your application to run. So in containers, what happens? So container does this job in a bit smarter way. Means so what happens, like instead of having the complete operating system here in this isolated box, here we have this operating system, while here we don't have any operating system. So it keeps this thing outside, so hence it become a very lightweight box. So what happens, so it just utilize whatever this application is running inside this box here. So it just utilize the host operating system via container runtime here, which is Docker. And it maintains the isolation between different containers, and it maintains the isolation between the operating system as well. Now, the container runtime, which is Docker here, it sits between the container and host operating system instead of this hypervisor. And then container can communicate with container runtime, and then this runtime communicates with host operating system to get the necessary resources for this application which is running here. So here, in short, it is actually eliminating the need of having guest operating system layer. So which is making these containers as much lighter in comparison to the virtual machine. Hence, these are like known to be a next gen of like virtual machine. Raja, do you want to add anything here?
Yeah, so the main thing is like when we run a complete virtual machine, it is again a isolated environment on top of a big server, which gives you a lot of freedom and you can do a specific setting. But the main problem here is like operating system. Each operating system in itself require a huge resources. So if you are allocating say 4 CPU and 16 GB RAM to one operating system, that operating system in itself need at least 2 or 3 CPU and say 8 GB RAM just to run its own virtual operating system, which is a very huge. Whereas Docker works on top of the same operating system. It shares the kernel of an operating system, which is very lightweight, and it does not run a full operating system inside a container. It just runs a minimal set of operating system which is required to interact with the kernel. That is where it is very lightweight and it makes it very fast to work as well. So with the same hardware, if you are running it into a virtual machine architecture, you would be able to run say 4 containers or 4 separate application. Whereas with the same hardware, if you're using Docker environment, you can run almost double or more than double of the application with the same hardware capacity. So it gives you a faster access along with saving on a hardware cost as well.
Yeah. So here the key benefits are listed when we use containerization. So as we discuss, obviously it gives us like better portability, that we can put like everything together as a container, as a box. These are more efficient, these are more agile because everything is like ready to use. We don't really need to install things again. We don't need to do configurations again. So it gives like agility and faster delivery. And uh, it also gives us improved security, and like obviously it is like less overhead, easy management of resources and your application dependencies, configuration, etc. So these are the key benefits of containerization which developer leverage these days. Moving on to this Docker architecture, Rajat, do you want to explain this?
Yes, so let's understand how actually Docker is composed of. So there are different components in Docker. So let's understand the first one and the main important component, which is the center component in this diagram, known as Docker daemon. So Docker daemon is the actual component, main server component, which is responsible for creating and building the container images, storing those images, managing those images, and it is also responsible to actually convert those images to the working containers. So this whole mechanism is managed by this Docker daemon, and then it is supported by other tool which is known as registry. So this registry, you can see it is outside Docker host. So this registry can be hosted onto a remote machine or onto a public internet, and Docker provides a free registry known as Docker Hub. We'll be discussing that in the coming slides. So this Docker Hub is hosted onto a public internet, which is a public registry where you can store images, you can push images of various softwares like Nginx, Ubuntu, or other systems. And then when you want to run a container, your Docker host connects to the registry, it downloads the images, make them convert to the containers, and start running them so that they can run the containers isolated environment on the Docker host along with Docker daemon. And another tool is known as client, which is a Docker command line interface. Docker CLI is known as, using which we can interact with the Docker daemon. So this Docker CLI is a very popular tool using which you can run commands to create images, download the images from public internet, and then running up your container, provide any configuration to the container. Using this, you can also connect inside your container as well. Like you can do a SSH to your running application, the running container, and from there you can make the live changes to the application as well. So these are the three major components: a client component for interacting with the Docker daemon, Docker daemon itself, which is a brain running behind the whole Docker ecosystem, which is managing network, which is managing images, which is managing the container runtime. And then the third component is a Docker registry, which is required to store and publish the Docker images.
Great. So, Rajat, before we move forward, can you just have a look if we have any questions on the chat?
Yeah, there is one question from Akash Rana. The Docker container host OS will always be same.
Yes. If we go back to this image, so here the host operating system is always the same for Docker. So this is the Docker runtime, which has all the intelligence, as Rajat just explained. In the Docker daemon is the brain behind this Docker ecosystem. So it like gives it has all that intelligence that okay, what kind of like files, what kind of runtime need to provide to your application, and how what are the resources actually required by your application. Sorry.
So if you go back, Dipali, on the same one, so Akash has a follow-up question as well. In virtual machine, can operating system be different than host and guest operating system?
Yes, of course. So, like, you can have any, let's say you have your laptop, which is like Windows laptop, and using some hypervisor on your Windows laptop, you can actually run even Linux, Mac on your like Windows laptop itself. So this is the hypervisor which lets you isolate your host operating system. Though underlying it is using the resources of your host operating system itself, but yes, you can run different flavors which are completely isolated.
So just to adding to the first question which Akash has asked, so it's a very important question, I would say, and it's very confusing for everyone who wants to use Docker. So what we mean by is a Docker, when we run a container, the container does not have any operating system inside it. It just uses a smaller set of operating system. That is why it uses the host operating system for its operation. So if the host operating system is Linux, you can only run the Linux based containers onto that Docker. And what if you want to run Windows based container? Then your host operating system has to be on Windows. So you can still run Windows container, but it cannot be run on a Linux host, because underlying kernel is the main thing. Because Docker interacts with the kernel and share the resources from the kernel itself, it is not a completely isolated environment. The container is isolated from each other, but they are not isolated from the underlying host operating system. So that is where it's a very valid question and a very important question to know. If you're using a Docker onto a Linux runtime, then you can only run the Linux based containers on that machine. Whereas if you're running a Windows based operating system, then you can run both containers, Windows based container as well as Linux based container. And how it happens is, like, nowadays Windows comes up with a smaller set of Linux, which is known as WSL, Windows Subsystem for Linux. So Windows subsystem for Linux enables Dockers to run Linux containers on Windows so that you'll be able to interact with the Linux kernel as well over Windows. But in that case, if you're using some niche application, or if you're interacting with the OS kernel, then you will not be able to get the exact features that you're getting on Linux operating system, because you are interacting with the Windows subsystem for Linux, WSL to be short. And in terms of host operating system in virtualization environment, host operating system is just to enable the capability for the hypervisor, and then each virtual machine has its own guest OS, which can be totally different from the host operating system. And guest OS can be anything. So in the same hardware, you can run Windows, Linux, as well as Mac OS. So you can run a separate guest OS inside a virtual machine. Just to answer that question precisely. Another question we have from Aditi. Dipali, maybe you can take this up. How do containers improve security?
Okay. So, like in containers, since everything is isolated here, like because you don't know that exactly what is running in the adjacent container on the same machine. So that's a means it is an isolated environment altogether. Means no one is able to even see that what is running inside this. So whatever you want to explore is, let's say I'm running this application A in my container and I want this application to be like usable from outside world. I need to explicitly export it on a port. So like I will expose this application on a specific port, so only that is the one connection through which it can be accessible outside like this container. Otherwise, it is a completely isolated environment. No one can even see what is inside this. So that's how it like, gives us like better security. Rajat, if you want to add any other perspective here.
Yes, you have already covered the Pali. So main thing is like each container has a separate, I would say, a operating system or a subset of operating system, a separate network component, a separate isolation. So it is isolated unit. Even it is running on the same machine, but it is an encapsulated isolated unit. So it is very secure in terms like one container cannot view the content of another container, and they cannot interact to each other until you make an explicit connection between them.
Yeah, even though like there is a shared hardware, or you may be having these applications running based on same image, but still if that is the shared software you can say, but it is not actually shared. So you don't know that exactly what this application, how this application is using that base image, how this application B is using the same base image. So there is like no connection between them. So hardware, software, everything is isolated here.
Yeah.
Okay, do we have any more questions, Rajat?
Yeah, there's one more question by Aditi regarding the registry. So I would say let's move to the registry section. Then we already cover that in the coming
Okay,
slides.
sure. So, do you want to cover this, though you have already spoken about these?
Yes, yes. So as we said, like Docker client. So you have a UI based client as well when you work on Windows. So there is a Docker desktop which you can run, using which you can create a container, you can create an image and manage a image as well. But the most popular tool is Docker command line interface, which is known as Docker CLI, which is used to interact with the any of the Docker which is running on your system, or to a remote Docker daemon as well. So you run a Docker login command, and using that you can connect with the Docker registry which is on internet or hosted inside your organization for downloading and uploading images. You can interact with the public repositories as well, and using this you can run the commands for Docker. So Docker image, I would say, is a kind of ISO file. You can consider it as a kind of a ISO file which contains a base operating system, and this image contains everything that is required to bundle inside a container. So this image includes a subset of operating system, a configuration files, source code, some settings, environment variable. This image encapsulate everything, and when you run the container from the image, that container get everything in a runtime. So container is nothing, is just a instance, running instance on top of image, and image is a actual blueprint which contains everything to make it work, to make containers work. Maybe we'll explain images in a better in the coming slide, but you can think this image as a ISO file which has everything, but it is a very lightweight file. And this image is not something you can view on your operating system. Like you cannot go to C drive and you can see a image. Docker has a very specialized mechanism for creating images. You can get the images with the Docker client like Docker CLI. You can see those images and you can publish those images, but it is being managed by Docker daemon. So it's not like a file like you can copy paste from one system to another system. There are some tweaks and hacks which are available, but those are not the reliable thing. The best thing is to copy image via registry only. But yeah, you can create a tar file, jar file, but sometimes it did not work, so that's not a recommended way to interact with images.
But yeah,
If
in like in simple terms, like if we try to understand, so images are nothing, it's just a template. So let's say you have created some application, hello world, where you are not doing anything, you are just printing hello world. You say, okay, this is my application template, and I want to run this, or maybe if not hello world, maybe we can say hello Aditi. So you want to see that, okay, in all my machines, I want to run this application. So you have created a template, which is known image in the Docker world, and you want to run that image in all your machines. So typically how it works, how these components are tied up with each other. So means you ran this command that run image, the actual command is docker run and then your image name. So let's say you have created image with name hello Aditi. So you will just issue a command docker run hello Aditi from this client command line. So what it will do, so this client will interact with your server, which is docker daemon, and here it has a like local repository of images. So here it will try to see that if it has anything called hello Aditi. So if it has hello Aditi, it will create a container out of that image and start that container. But in case this image is not found in your local repository here, it will go to the registry, which is a public repository. So it will try to look for that image in the public registry and then pull that image into your local repository and then create a container out of it and make it run. So this is how this entire process works. Sorry, Rajat. Yeah, let's move on
no,
to
no,
this one.
fine. So we already discussed like Docker daemon is the main brain or main ecosystem of the Docker, which is responsible to manage and interact with registry, create and build images, publish images, and interact with the Docker client as well. And this Docker daemon is actually which is responsible for converting the images and running them as a live containers. So Docker daemon is the main component. Then we have a Docker registry. So maybe we'll show one example, which is Docker Hub. Dockerhub.com is a live Docker registry where you can find lot of public images which are available. You can also create your account, and you can create a private area. You can publish the images which are only visible to you and your organization, and in case you want to make them public, you can make them public as well, so that it will be available to everyone.
Yeah,
So
so the
Docker
key thing
registry.
to,
Yeah.
sorry, I was just adding that key thing to understand here, like whenever you are using Docker, whenever you are creating your own custom images, you always need to have some base image which is published into this Docker registry. So you will take a base image from this repository and add your customization on top of that and create your custom images. Then if you want, you may or may not publish it back to this registry. You can keep your images local, and you can make your images public. So it's totally up to you. Then yeah, Docker container. Rajat already explained. Rajat, do you want to talk about this Docker Compose as well?
Yeah, so what happens is like generally when we work on application, we work on end-tier application. Like we design some UI interface which user can use to interact with the application, like any form or a button or a textual inputs a user can give. Then we have a middle layer which is primarily API layer nowadays, or known as business or middle layer as well. And then we have a third component which is a database. So one way is like you bundle everything inside a single container. Like a single container should contain a database, a business API, as well as the UI component. But it makes very rigid for developers to do changes. Like you cannot do a parallel development, you cannot do agile deployment. That is why people prefer to use n-tier architecture, which means running UI as a separate component in a separate container, then API into a separate container, and DB into separate container. So if you are having multiple instances of the application, like you're running a production grade application, then you may have 3 or 4 containers for UI because of the scalability, 4 or 5 containers for API. So it becomes very difficult to manage these containers. So that is where Docker Compose comes into the picture. So Docker Compose is a tool using which you can define how the containers are linked to each other, which containers are dependent on each other, how they can interact with each other. You can define a networking component inside each container, and it gives you an easy way. Like with just one command, you can manage a complete ecosystem, complete application architecture, which will be divided into multiple containers as well. So if you're playing around with single container, then Docker CLI is good enough. But if you're playing around with multiple containers for the same application, then there's another tool, Docker Compose, that help you to organize those things. You can do it as in a separate way as well, but Docker Compose is there in case you want to organize easily.
Okay. So now next we want to
So
see what is.
yeah,
Yeah, sorry
before
Rajat,
Dipali we
please.
rush. Yeah, so
Mm,
there are some questions there. So we have a
okay.
question from Hari Om Babu. So in
Mm-hmm.
Docker, are they share hardware which with host OS? Yes. So Docker share the hardware with host OS because it runs on top of host OS only. So that is why operating system is shared with containers and host operating system. So it uses the same, yeah, CPU and RAM from the same host. So if you're running your Docker on your local desktop, so you may see like Docker is consuming lot of resources from your desktop itself. Then we have another question from Akash. What are your views on EC2 plus ASG, which is Application Security Group, versus ECS, performance pricing complexity? So, Akash, I think it's not a topic for today's session, but yeah, we'll try to give you a gist. We'll be coming up with another session in this series for ECS. So, in that, we will cover this in detail. So you can, when you go to the cloud, one way is like you can do a lift and shift approach. You can create a EC2 machine, and then you can set up everything inside your EC2 machine, which is like setting up a Docker daemon inside one EC2 machine. So what if you want to scale, you can do vertical scaling, like you can increase the CPU RAM capabilities into EC2, but it runs into its limit as well. But in case you want to do horizontal scaling, you will add one more EC2, so you need to manage another Docker on it. You need to set up Docker again and manage everything again. That is where ECS comes into the picture. If you need scaling, you are running thousands of container in your organization, so you don't need to manage each and every Docker instance manually. You can use a serverless capability provided by ECS, and that ECS will manage everything for you. So there is a cost difference for each other. Again, we are not going into depth, so each choice will have its own cost and performance implications. So I would say in case for scalability, ECS would be a right solution, but in case it's a small application or it's just one or two application, then you can go ahead with ECS EC2 only. And then we have another question from Akash, which is regarding pulling and pushing images to registry. Will name need to be unique while pushing to public registry? Yes. So whenever you publish to a public registry, it is important to have a unique name, otherwise it will be overridden. So if someone already have a public registry name Ubuntu, so you will not be able to use that name because it is already consumed in a public way. So you'll not be able to publish that. Only the owner will be able to publish that, and it has to be unique. So whenever you publish, it has to be a unique name over the internet, otherwise it will be overridden. Yeah, Dipali, we can
Okay.
go further.
All right. So now next let's have a look at the Docker Hub, which is like Docker registry, which we are talking about. So here means this is the link. So let me go out of the presentation mode. So this hub.docker.com, this is the link through which you can actually log into the like Docker registry. So when you are using it for the first time, then it will ask you to set up your credentials. But since I have logged in here a couple of times, so I can directly log in. So here you see, like I have just published one image in this account, that hello world. So this is the only image I have published. But since it is a public registry, all the images are available here. So here in this slide, we have like picked one example, this image, which is a game 2048. You might be aware of that. So let's try to look for this image in the this public repository. So this 2048. So here it gives us like different images which are available. So this is the one black eyes bird in which we are interested. So we want to see that okay, what this image is and how to use this one. So you can see some overview, you can some tags, means some brief information about this image, and this is where you can see the like command that how to use this image. So if you need to pull this image from this repository, there's a simple command docker pull and then your image name and the tag. So you always pull the latest image from this repository. So this is how this latest tag is there. Rajat, do you want to add anything here?
Yeah, so whenever you publish any images, you can specify tag. Tag is just a version or a identifier using which people can understand what is there inside that image. There is a tag which is known as latest, which means the last updated image will be used. So whenever you download any image, if you don't provide any tag while downloading, it will always pick up the latest image from the Docker registry. And if you release different versions of the images, then it is important to do the tagging. It is just a image versioning so that you can use that. And this image that Dipali is showing, black ice bird, is just a simple UI based application which runs on Node, and it is a 2048 game in which you need to combine numbers and make 2048 number to win the game. And maybe we can show a simple example how you can run this game into a Docker container as a Docker container on your Docker host.
Yeah, so if we have set up Docker already on our machine, we can simply pull this image and play around this one. But apart from that, there is also a playground available for us. So link is here. So this Docker playground is available where we can just explore these images just to understand that exactly what it offers or something. So if we go to this link, Docker playground, it gives us some already running containers, and we can use these containers for 4 minutes of duration. But yes, if our session is active, it will add again 4 minutes for you. So here it gives us this Docker session. Uh, Here I can add instance. So here I simply got a machine where like Docker is all set up. I really don't need to do anything. I can simply pull the image and start using that. So for this one, let's go back here and copy this command to pull the image. I think I have mentioned few more commands here. So we can simply just first of all check that what all processes are running here, and then we can pull this image and can check further details. So let's say I just want to see on this environment which we have got what different processes are running. So currently there's nothing. Let's, not sure if can't I copy paste here? I guess not.
Yeah, I think yeah, copy paste will not work.
So let me pull this image, which is like Docker pull and black eyes bird slash 2048. That this is my image name. Black eyes bird. So this is the image name we are pulling, and it's like good practice to provide your tag. But if you are not providing tag, then it will by default pick the latest. So this is how I instructed it to pull. So this is the like Docker client, Docker CLI. So with this Docker CLI client, I requested that okay, pull this image. So here, like it has pulled this image from the registry. Now, if we simply try to see if this image is available here, I can say Docker images, and I can see that okay, this is the image name, this is the latest tag, this is the image ID. So I get to see some details here. Now I can run this image using some command. So by default, means if you read the image documentation, so means it says that this image is actually exposing a port 80, means this application is running at port 80 inside Docker. So this is the command to run any like Docker images here. So Docker run hyphen p for port. So here you provide the port mapping. So here this right hand side is the port on which your Docker application is exposed, and this left hand side port is where you want to run this application at your local machine. So let's say here we are saying that in my local machine also please run it at port 80, and it is running at port 80 in the Docker as well, and then your image name. So if I provide this command here in order to run this image, and the image name which is same black eyes bird slash 2048. So here I have run this Docker image at port 80 in my local machine. And how to access this one? So here in this playground, or means if we are into our local Docker environment, we need to really open this port 80 here. So this is the point through which you can actually open this port. So I'm saying that oh, please open port 80 for me. It has opened the port 80 and it has ran this application on this port 80. So this is how you can see that some application is running, which is like 2048 game. So here you can just start playing this game and yes, try to make it like 2048. And if you want to like customize this application further, you can take it as a base image, add your customization, and can improvise this. So this is just a playground to give you an idea that this is how, maybe this is a quick way to see that exactly what this image is offering. And you can just try your hands on there without getting into the overhead of setting up containers, Docker at your local machine. Yes, Rajat, if you want to add anything here.
Yeah, just like as Dipali mentioned, this Docker Playground is a very good tool. It is a virtualized environment provided by Docker itself, using which before installing Docker, you can explore and you can do a lot of exploration free of cost on the public internet and before setting up your own environment. And now we'll talk about in the next session how you can set up a complete working Docker environment on your local desktop or laptop, and then you can start your development.
Yeah. So now let's say we want to build our custom images. So how do we do that? So far we understand that yes, Docker images are nothing. These are templates. These are like some lightweight standalone executable packages, which includes everything need to run on the application, which is like your code, runtime, system tools, system libraries, and settings. And in Docker, when we create images, there is a specific template. There is a specific template like Docker file is the file name. is a default file name, and it has its own structure. So this is a specific template we need to follow in order to create any custom images. So how this Docker file looks like? First of all, you have like from. So from, like, where you need to define the base image, that which base image you are taking from repository to further develop on that. So here we have mentioned that, okay, we are using this base image, which is Node Alpine. And then with work dir, we are defining the working directory in our local environment. And then we are with copy, we are copying all these like packages. This, like as I mentioned, some description here. This copy is actually adding files from your Docker client current directory to your working directory. And then with run, you are installing any dependencies for this application. So here we are running npm install. Then you are copying everything to your like working directory, and with this command you are actually providing a command which is like your like Docker client instruction, I would say, that okay, npm start. So here you are actually running your application. Generally, you will see one more keyword here, which is expose, where you define that exactly at which port you are exposing this application in your Docker. So here we have not defined that, because you know what happens, like by default npm start, by default npm runs at port 8081. But yes, otherwise it is a good practice to like define like expose keyword here, and you can simply say expose at port 8081. So which signifies that okay, this is my Docker application which is running, which I'm exposing at port 8081. Or if I don't want to use this default port, I can actually mention any port here. So you can define any port where your Docker application is running. So using this Docker file, we can actually create image. So here, if you see the command to create images, Docker build -t and then your image name. So I can provide any image name like test image. So by default, it will look for the Docker file in the same directory, and it will create a image using this Docker file. And we will be doing all these things in a while. And once you have created your image, then you can run this image in container, as we did it like just earlier. Docker run -p, then port mapping, local port, container port. So in this case we can say, let's say local port is 80 and container port is 8090, and then image name, which like test image, which we given here. So using this command we can actually run our application using this image which we have just created. Rajat, if you want to add anything here before I move forward.
No, I think I'm fine. You already covered a lot of things.
Okay, great. So here, just to give you an idea, because today in today's demo, we are going to use a Linux container. So just to give you, if you set up this Docker on your Windows machine, so it gives you a great GUI where you can see, means in case of Linux, as you like noticed on the playground, I explicitly did Docker images in order to list what images are present. So on Windows, it gives you a nice GUI where you can, if you simply go to this images option here, you can see various images which are running in your account. And the next image is showing what are the different containers which are running your account. So Windows comes up with a great GUI, and it is known as like Docker Desktop. Rajat, anything to add here?
So this Docker Desktop is a very good tool using which you can create images, run containers. You can see like if you go back to the previous screen, the previous slide for images.
Mhm.
So if you select an image, you can just right click and run the container, and you can also see like under images, it has various tabs, like it is a local image, it is on a hub like Docker Hub, or it is on a public artifactory. So other than Docker registry, you have other tools as well, like GitLab, GitHub, Artifactory, on which you can publish your images. So if you work in an enterprise environment, like in any organization, they will not be pushing their Docker images to the public registry like Docker Hub, most of the organizations set up their own registry, and they publish their artifacts there. So you can use this tool to publish the artifacts and download from there as well. And when you work with specifically with the Amazon cloud, which is ECS, Amazon Container Services, then you use a registry tool provided by Amazon itself, which is known as Amazon Registry. So we'll talk
And
about those things in,
sorry,
yeah.
just to interrupt. So now here it comes with a quiz question. So can anyone name like what is the images repository service which is there in AWS? And you may win that AWS credits by answering this one. Pretty fast.
Can I answer?
No, obviously not. You can answer if no one is giving the right answer in, let's say, 2 minutes. But yes, you will not be getting any credit, Rajat. I'm sorry.
Okay. So guys, don't do Google. Yeah, if you know the answer, please jump into chat and write in the answer. Okay, 10 more seconds to go. So we don't have the answer.
Okay, that's surprising. So now, Rajat, you can actually reveal that what is the answer for this one.
Yeah, so it is known as ECR, Elastic Container Registry. So Amazon provides its own registry. So whenever you have to run any container on Amazon ECS, then you need to first publish your images to ECR inside your own AWS account, and then you can run containers from there. So
Yeah.
maybe we'll cover
And
that in detail in the upcoming sessions.
yes, that's what I wanted to say, that we will cover these ECR and ECS in the upcoming session. All right. So let's move on to this. Like now we will get into the hands-on side of things. So now let's set up this Docker on a Linux machine. So to set up this, considering I'm using Windows laptop, so I will be leveraging like EC2 machine. So let me log into my AWS account. I hope you guys are familiar with like AWS Management Console, have some basic knowledge around that. So here I'm simply logging in with into my like AWS account using my root user actually, which is not a good practice. So those who are not familiar with AWS Management Console, once you log in, this is the like landing page which you see. This is the home page where various services which you have used recently are listed. But otherwise, there is a like services, the style icon you can see various services which are available in AWS. You can look for services, you can look for their description. So for example, in compute section, we have like various services available here, and we are going to use EC2, which is a compute service through which we can create virtual servers in the cloud. So this is the service which we are going to use. So either I can click here or I can simply search for any service here in this search box, and or I can simply launch it from the recently used services section. So here, if I go to instances, I want to create a new instance. So I'll go to launch instances. I can provide any name here. Let's say Docker demo. And then, so here when I'm creating this virtual machine, the concept is same. In case of virtual machine also, like we pick a base image. So here, since I want to create a Linux machine, so I will pick the Linux image here. Otherwise, you will see the images of various flavors of operating systems are available here. So you can pick any image and create any that kind of virtual machine. So let's stick to Linux here, and then here we need to choose the instance size. So T2 micro, it gives you like one CPU, 1 GB. But since we need to like install this container, etc., let's pick a slightly higher version of it. Let's go to T2 small. Rajat, is that fine?
Yeah, T2 small should be fine.
So in T2 small, the only difference is there is only one CPU, but I'm getting 2 GB memory. Then we can create a new key pair if we don't have it already. So meetup 15th June. We can give any name actually. And since I'm using Windows, I am fine with .ppk file here. I'm not explaining all these details, assuming that yes, you guys are familiar with AWS basics. In case not, please drop that into the like chat box so we can plan a session around these like AWS basics. Okay, rest everything I'm just keeping default here uh, and simply launch an instance. So by doing these steps, what I'm doing, I'm simply procuring like a machine into this AWS. So here we can see the status. Currently, this instance status is pending. It should be available in a minute's time. So now we can see it has changed to running. So this instance is available while like it is performing some status checks as we see this tag initializing here. But yes, since it is available, we can actually log into this machine. So let's go to connect. So this is like quick way to connect via like console itself. Otherwise, you can actually connect to this Linux machine using some tools like Putty, which are like your Linux tools, Linux clients. So this is where we have simply logged into this machine in AWS. Now we need to set up Docker on this. So these are the commands listed here in order to install and set up Docker. So first of all, we want to take any updates so that our machine has got latest configuration. So though since we have just created this machine, it must be up to date. And then with this command sudo yum install docker, like we can install Docker. But just please keep interrupting me wherever you feel like adding something.
Sure, sure. It's going good. So we have an answer from Akash in a chat now, but I think is it late or we can still consider the answer for the
So,
quiz?
so answer is correct or not?
The answer is correct. It's ECR.
Great, good, well done, Akash. Yeah, we can consider because so far I think I have heard just Akash and Aditi's name that they are asking some questions. How about others? Are you not following up anything? Whatever is the status, please let us know so we can actually plan these sessions accordingly. We can plan the pace, we can plan the content according to the audience. So just let us know what is your level because like it's very difficult in virtual sessions to assess that exactly what your understanding level is because everyone has like different set of expertise. So if you are new to this word and just want to learn, because this session we planned it for a little deep dive, assuming that yes, you already have some basics around AWS and little bit basics of containers as well. But in case you are not getting anything, so please let us know so we can plan a very basic session or maybe a hands-on workshop with you guys. Okay, so with this, this Docker install is complete. As a next step, what we want to do here, we simply want to start Docker daemon, which is nothing like Docker server. It is started, and then by running this command, so here I'm simply running this Docker run hello world, which is like image available in the public repository. So we are just verifying that yes, everything is fine or not. Okay. So here, if you see, it says that it is unable to find image locally because this is the first time I'm using this. I don't have any local repository or something. So it could not find this hello world image in my local repository. Hence, it pulled this image from the library, from the public repository, that is Docker Hub. So it has pulled this image which had this latest tag. So this is how we fetch the image, and this is the process which we discussed when we were discussing the architecture. That if image is present in your local repository, it will just like run a container from that local image. Otherwise, it will pull from the public repository. Okay, so now we need to enable Docker as service here. So these are like part of this setup itself. So you are enabling it as a service, and then you are adding your current user to the group. So your like user has required admin sort of privileges to run Docker commands, and then with this command, I'm just switching my group to Docker. So till this point, we are done with the like Docker setup on this newly created Linux machine. In next slide, what we are saying here, okay, now we want to run a single container app. Rajat, before that, do you want to add anything here? Some context?
No, no, going good. So till now we have just set up a EC2 machine on AWS cloud because the session is about how to run containers in AWS. So we're using a standard method as of now. Like we set up a EC2 machine, and inside a EC2 machine, Dipali has just set up a Docker daemon. If you're talking about architecture, so we have set up Docker daemon mainly till this step. Now Docker daemon is running, using which we can set up the containers inside EC2. So we tried with Hello World as well to run a Hello World container. Now we'll see how we can run an actual application inside a container.
Okay, so far we have not created any application or something on this machine, but yes, we have a pre-created application which we have uploaded to this S3 bucket. So we are trying to get application files here into this EC2 machine from this S3. Uh, okay. So I'm saying wget and then this S3 link. So it has downloaded this myapp.zip, which is mentioned here. So it has downloaded this application files bundle as a zip file on my this local EC2 instance now. So as a next step, we want to unzip that. So it has unzipped, and we can see it has created, it has unzipped into this directory, my app. And then inside this directory, we have like different folders that we have front end running, all the front end related stuff in this directory, all the back end related stuff is there in this directory. And we also have a Docker compose. So for this demo, we have picked this application, which is containing like multiple images. So there is one image through which like front end is running. There is another image through which back end is running. So, but yes, let's go step by step here. So here means when we have downloaded our application bundle, so what we are trying here, first of all, we want to run a single container app. So first of all, we are trying to see that, okay, if I'm simply just running my front end container, uh, how the application is looking like, and then I will try to run it like as a bundle, including the backend. Can anyone quickly name it? How we can like run it as a bundle? Rajat covered that during like when we were discussing those slides. But all right, while you are responding to that, so now since we have all the application code available here, so what we are instructing here, since I want to run my front end image, so let's go to this front end directory and then we will create Docker image using this command. So let's go to this front end directory first. And if we simply do ls here, we can see like we have a Docker file here. We also have a dockerfile.dev here. And we have few other files which are like used as dependencies into my front end application. Now, in order to create image, we are using this command here. Let me show it on the slide. Docker build -f dockerfile.dev. So what is happening means when we create image, by default it takes the name as Docker file. But if I want to create image using some different file which is not named as Docker file, we need to give this switch -f and then we can provide the file name here. So this dockerfile.dev, let's just check the content of this file first before we actually run this. So this is the file which we are using in order to create only the front end image, because this file, it has the content through which like we can create the image for the entire application, but let's not get confused with this. So for just front end application, we have the instructions available in dockerfile.dev. So if we simply try to see the content, so this is the same content which we had on the slide. What we are saying that we are using to create this front end, we are using this base images of Node, and then we are defining app as our working directory. We are copying these package.json, whatever different files are available here, which are needed. So we are just copying the required files to this working directory, and then we are like running this application on npm via npm then we are actually installing the npm and running this application. So now let's create this image using this specific Docker file. This image creation will actually perform the various steps here. If you notice that it is performing first step, now it is setting up your working directory, copied the packages, and then in this step it is actually installing the npm. So once this image is available here, once this image is created, we can actually run this image in order to run this application. So when we run this image, it will create a container, and in that container, it will run this application.
So till the time it is building up, we have answer from Akash Rana. He has rightly answered Docker Compose. Also, Aditi correctly answered this as well. So we have participants who are active. Great.
Great. So at
So
least
Dipali,
two
how we
active
can share?
participants.
Yeah, how we can share credit with them? I think they can post their email
There,
ID on Meetup.
no, they can even post in the chat itself. So
Okay.
please share your email IDs. So we will email you back with the AWS credits coupon code. So you can add those credits into your AWS account and keep exploring.
So there is a question as well from Dev Mehta. What is the Docker group? Can you please explain a bit? So I think when you were installing the Docker, there was a command to set up a Docker group. So he
Mhm.
has a question like, can you explain that further?
Yeah, that maybe you can go ahead. Let me switch to that slide. Mm, yeah,
Right. So the purpose is whenever we install Docker, so it install with its own group name as Docker. So what happens is like if you're running outside this Docker group, so you need to use sudo many times inside the commands like sudo docker, then create image and other things. So what we have done in this step is like the current user, we have modified the current user, which is like who am I. It gives us the current user, and we have added the current user to the docker group, so that whenever you run commands from the current user, you will be able to interact with the docker directly, because you are also part of the same group now, user group now. Otherwise, every time you have to use a sudo command or other commands, which will give you trouble, and the commands will be difficult to run. So that is why this step is done, to adding the current user to the Docker group, so that the current user can perform any command onto Docker.
yeah. And now it calls for another quiz question. Can anyone name like what was the current user in this case when I was running this command on this EC2 machine? Meanwhile, let's see if npm install is done.
Great, we have a right answer from Akash Rana, EC2-user.
Okay. Akash is a clear winner for AWS credits.
Balaji, we have answer from Balaji as well.
Great.
Great.
Good to hear. New name.
Aditi is saying EC2 dash to user. It's EC2 dash user, but yeah, it's same. Looks like a typo there.
Maybe typo. Yeah. Great. Well done. So yes, when we are using like EC2 machines with Linux flavor, so the default username is EC2-user. So by use means by adding, so we just added this EC2-user to the Docker group, so it can run like all those Docker commands without any elevated privileges. So now means all the steps are done. So here in the last step, like it has done this npm start. So it has started, like it has created the image. So if we say like Docker images here, we should see this newly created image here. So this is the image which we have just created with name tutorial React app. And this is the image name which we provided when we like issued this command. Now, as a next step, we can actually run this image. So to run, the command is docker container, and then we will explain these switch in a while, and then port mapping with hyphen p. So what we are saying in Docker, it is running at port 8081, while at local machine, I want to run it at port 3000, and then your image name. So let's run this image here. So it has given this ID. So if I simply say docker ps-a, some typo. So we can see this, that this is the container ID in which this specific image is running, and it has just created like 16 seconds ago. So how to access this one now? Any guesses? So in order to see what is running means when I run this image, how to access this application. So one way is like since I'm running it on EC2 instance, so I can take the public IP of this EC2 instance And since I have instructed it to run at port 3000 on my local machine, so I can try to see what is available at port 3000 at this machine. Because if it is running this application, I should be able to see here. But yes, it is not really able to access it yet. Site can't be reached. Can anyone tell me the reason why I'm not able to access this application here quickly in interest of time?
So Balaji has added into chat like with instance public IP, but we need to open port 3000 in security group.
Bang on. So yes, that's the reason because we have not given its given instructions that okay, this application can be accessible at port 3000 in my local machine. So I need to open this firewall here. So here we are into the security group. Let's open and added this security group. And in inbound rule, let's allow all the traffic coming from this port 3000, which is coming from internet, save rules, and then let's try to access this application again. Here you go. So we can see something is running. So we can see this is the front end application which we have. Rajat, maybe you can explain about this application a bit.
So this is just a simple node application which is designed as a single page application architecture, which means the UI part is just a plain node based architecture, and it makes a call to API using JAX calls using jQuery to get the data. So as of now, we don't have any backend running. That is why you don't see any data coming onto the page. But yeah, if you make your backend running, then you can see this application working. So this performs a kind of a CRUD operation, which is create, update, delete, and read the details from a table, which is a tutorial account. So you can read all these details around a tutorial object. So this UI is being created into Node. Yeah.
Yeah, so it means we don't see that it is displaying any data which is coming from database. And if we try to add anything here, like maybe test, so means nothing is happening. It is not actually adding that to database because there is nothing which is running. Means this application doesn't know if there is any like backend with this application. So that's what we will be like doing as a next step, that we will be like making its backend also available using like Docker Compose, and then we can see this as a like full-fledged application, tutorials application, which is performing all the CRUD applications. Okay, I think I need to be a little fast in interest of time. So I hope like so far things are clear to you guys, but in case there are doubts, keep on posting them onto the chat and feel free to reach out to us even later. So now as a next step, so we want to run it as a multi-container application where we can actually like bring the backend also into the like action. So in order to set up Docker Compose, here are the commands that first of all we are just grabbing this Docker Compose where Rajat, in which directory I should be doing this?
You can do it anywhere. It's better to do it in my app,
Okay,
but yeah, it's just an installation.
yeah. So here we are simply installing the Docker Compose and then changing the permissions. We can simply verify if it is like installed successfully by checking its version. So yes, we can see it is available. And then we need to make a little tweak. So if we go to our application script, which is available into this services folder, so if I simply do ls, go to this directory here, and cd front end. Then it's available into the source directory inside services. Let me do ls. So then we have this services directory here, and then here we have this script tutorial service.js, which is our actual application script. So if I open this script, and here we are saying that okay, run this, the application URL is like localhost colon 5000, means this application we want to run at port 5000 at localhost. But since we are using this EC2 machine, so rather than localhost we need to provide the EC2 machine's public IP. So let's replace this localhost with public IP of this EC2 machine, so this application can run. Save the changes. So here we have like make these changes, this added this file, and then I'm just going back to my like application directory because that is my working directory, and that is where I will actually run this docker compose. Okay, so currently I'm into this services directory. Let me go back few level back, and I'm into front end. Now I'm into this my app, and this is where I need to run my Docker Compose. So now Docker Compose will actually be creating an image, which is the combined image of your front end and back end.
So what this Docker Compose will do now is like we have configured to set up a database first. So it will set up a Mongo based database into a container. Then it will create a separate container for API, which is written in Python, which is known as backend folder. So if you download this my app file, my app zip, you will find a folder named frontend, which contains a frontend code, node code. Then you will find another folder which contains backend code for Python Flask. It's a API written in Python Flask. And then in your Docker Compose file, you will find the configuration how we are setting up MongoDB, and we are setting up this all three containers as a single app. So using Compose, we are running all these three containers as a single application.
So I have just shared the link to download this PPT from GitHub in the chat. And here are the links of my courses which are available on LinkedIn as I promised in the beginning.
So this may take some time because it is creating three containers now.
Yeah. So yes, we are happy to take any questions. Raja, do we have any more questions on the chat?
No, there are no questions in the chat, Dipali.
Okay.
We already covered all.
And do we have the email IDs of Akash and Aditi?
Not yet.
Akash and Aditi, if you want AWS credits, please share your email IDs so we can share the credits on your email. So once this combined image is available, then we will like try to access this application on port 5000. So as we know, like we need to open this port in our EC2 security group as well. So let's do that meanwhile. So once this is complete, we will try to access it on port 5000.
So generally you saw when you're building an image for the first time, it takes a lot of time because it download first the base image from public internet, then it performs other steps for copying the code into the image and then building the image. So that is why it is taking some time. But if you run it for the next time, second time, it may take even 90% lesser time.
Yeah. And while it is running, let's show you like here I have this my app folder. So this is what is there into this Docker compose dot YAML. So let's have a quick look on this Docker compose. So this is the file when you want to combine your different containers. So this is the file you need to write. So maybe Rajat, you very well explained this one. So you can.
Yeah, before that, Dipali, I could see Aditya and Akash are facing issue sharing their email ID. Looks like YouTube is removing them. That is why we're not getting it. So YouTube is not allowing them to put the email ID into chat.
Or maybe so rather than saying using the at the rate symbol, you can simply write in plain English at and then the domain Gmail or anything. Just try it that way. And if that doesn't work, you can actually respond onto the meetup chat
Yeah,
and
Meetup, or they can reach out to us over LinkedIn as well.
yeah.
Just give us a message on
Okay.
LinkedIn.
Okay. So here I have got an error because means front end was running on port 3000 and which was already running. We were already using this port in my case. So I think we should have actually detached that first.
Yeah.
So currently I will not be able to see it at 5000, isn't it? Let's see. Hmm. So this is not successfully completed because I'm using this port 3000 already. So I will need to really redo this.
No, no. Can you
So
do Docker PS minus A?
yeah.
So look like front end was already running.
Mm.
That is why it was there. So if you say Docker
Mongo
stop,
is there.
yeah, if you say Docker stop and then stop the front end app which was running earlier with the name tutorial app, right? Just stop
So
this
this is how
container.
we are stopping this container using docker stop command.
Yes. Now do
And
Docker PS minus A. Yeah, it is
so we
exited
can
now.
say
So
it is
now say,
exited.
yeah, Docker compose down. As I remember, we were using Docker compose up. Now use Docker compose down.
Okay.
Down minus D. So it will shut down. Maybe D is
Mhm.
not required then for down. Yeah, so it is just shutting down all the containers that we run. Now then Docker PS minus A, nothing should be running. Yes,
Yeah.
so it has removed the containers that is being set up by Compose. So that is what another important is. You can manage the whole stack with Docker Compose. You can manage it as a single unit. So if you say up, it will manage all the containers which are there. And if you shut it down, it will also shut down all the containers. So you don't have to remember the sequence. You don't have to manage it manually when you do it. So if say right now it was 3 containers, still easy to manage, but think of if you have an app which is having more than 10 or 20 container, Docker Compose can do a lot of easy stuff for you.
Great. And since we already created these images earlier, so this time it is quickly like complete because it could see everything available in the local repository. Uh, I need to run at which port?
3000,
3000.
so 5000 is running API, we can see API is running.
Okay.
Now in 3000 we can see our app is running.
So here, now let's try to add something. So we were using some book, maybe. Okay, I can simply say test and submit it. So this time it gave us response that you submitted successfully. And if we go back to the home page, we can see that now this list is popped up from database. That in database, it could see this book as test, and we can see all the list available here. So now we can see that front end and back end both are working. Anything to add here, Rajat?
No, I think good. The only problem I could see is like people are saying even with at as well, it's not allowing.
Okay,
So the
please share
option
it
is
in
like,
the meetup chat. Yeah,
yeah, meetup chat
meet.
would be a good place.
Yeah,
So we are taking the note of your name, Akash Rana and Aditi Changla. So we'll try to reach out to you from the meetup.
or we have given like our LinkedIn profile IDs. In case you like find difficulties to like post it on Meetup, so please like ping us on the LinkedIn.
So there is one request from another person. He is asking for further advanced session on this topic as well.
Okay. So maybe like when you say further advance, we would be like keen to understand that exactly what topics you want us to cover. Um,
So
but yes,
Balaji has requested for further advanced session.
okay. So yes, means we want to really explicitly understand when you say advanced, what features, what specific like concepts you want us to cover, so we can plan that accordingly. But yes, otherwise in our plan, we have planned a next session where we want to cover like uh, using the like ECS, like the container service which is available on ECS. So today we showed a flavor where you are doing a kind of lift and shift where you are setting up Docker yourself on EC2. But as a next step, how to ease out these steps using the ECS and ECR. So next session we have planned around those lines.
Yeah, so
But
Balaji is asking for session on ECS.
okay, so that is anyways in the plan. So we should see that like in couple of days. So stay tuned on Meetup. You will see that announcement soon. Okay, Raja, do
Great.
we have
So I would
any more
expect,
questions? Otherwise, yes, I think we are done for the with the planned content.
yeah, I think we're good. So I would ask participant to go ahead and follow the lab, whichever we have shown. We have shared all the contents over public internet as well. All the links are available. So just follow these steps and you should be able to run your application, and you can reach out to us over LinkedIn or Meetup if you face any issues, or in case if you have any feedback as well, then reach out to us and look forward to the upcoming session.
Yeah. Safer side, let me also provide my email here. Let me stop sharing first because this. Okay. So I'm just providing my email ID, not the complete one. So I'm just providing the pali.kulsrest and then you guys can add at the rate gmail.com. Okay. So you can like email your maybe queries or your email IDs, especially Akash and Aditi. So we can help you with that. But yes, Meetup is the great place to keep these interactions. So this playground, yes, I can share in the chat as well. But yes, it is part of this slide deck. But yes, for simplicity, let me post it in the chat as well. Great, Aditi. I'm assuming it is like Aditi Jangra 2005 at gmail.com. Fine. So this is the playground link. You guys can like explore. And yes, if you really want to learn these like concept further, so please make sure that you are sparing some time over the weekend and practicing this hands-on exercise. So you can actually catch up with that, and you can follow us along in the next session as well. Thank you for your time. Thanks very much.
Thank you, everyone. Thanks, Dipali.
Thanks, Rajat.